Alright, so what we're going to be looking at in this last section is we're going to be looking at something called the quadratic formula, which is another way like completing the square or factoring. It's another way of finding your zeros for a quadratic function, so finding where it intersects the x-axis. And this is one that you can always use this. So if you ever are looking at any type of quadratic function, you go, I just can't figure out what it is, you can use the quadratic function or the quadratic formula to be able to figure out what the zeros are. Okay, so this formula will always work. Okay, and that's the formula down there, which is right here. The quadratic formula basically tells us where the zeros are, where the x. So it's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And it finds the zeros. So as you see, this actually comes up with two separate answers. You get negative b plus the square root of b squared minus 4ac and all over 2a. And you'll also get negative b minus the square root of b squared minus 4ac all over 2a. And then you'll just simplify these for your answer. Okay. Right, and sometimes you'll come up with imaginary numbers and numbers that don't come up as nice round numbers. Well, if you remember the formula, remember in standard form, the number that's attached to the x squared is the a, the number attached to the x is the b, and the number that doesn't have a variable is the c. So in this case, we would go negative b, which is negative 4, plus or minus the square root of b squared, which is negative 4 squared, minus 4 times a, which is 1, times c, which is 3. And that is all over 2 times a, and which a is 1. So then you simplify, getting us 4 plus or minus the square root of 16 minus 12 all over 2. 4 plus or minus the square root of 4 all over 2. And then from there you'll be able to simplify the rest of the way. Okay. So again, it's just you plug in those numbers and then just simplify it down. Simplify it down. And as you see, we get two answers here. We have 4 plus 2 all over 2, and we have 4 minus 2 all over 2. And these you'll get two answers, more than likely, unless you get a 0 underneath that radical. But we'll talk about that in a little bit when we talk about discriminants. Right? So that would be your answers. And it tells you what the 0 is for any quadratic function. And so it's a nice way of just like, oh, hey, I want to figure this out pretty quick. You just plug it all into the function, into that formula, and then just simplify it, and it'll tell you what it is. So now if we look at this one, your 15 is your A, your B is 2, and your C is 1. So for here you would have negative 2 plus or minus the square root of 2 squared minus 4 times A, which is 15, times C, which is 1, all over 2 times A, which is 15. Now if you see here, if we look underneath the radical, we end up getting 4 minus 60 all over 30. Okay. And with this, you see we get a negative underneath the radical, in which what we talked about a little bit previously about complex numbers and imaginary numbers. Since you have a complex number and an imaginary number underneath, you're going to have to break this down. So 56, 2, and 28, which breaks down to 2 and 14, which is 2 and 7. And as you see, a 2 will come out along with the I, giving us a negative 2 plus or minus 2i square root 14 all over 30. And then we'll reduce this, getting our answer as x equals negative 2 plus or minus negative 1, not 2, negative 1 plus or minus I root 14 all over 15. So again, all you're doing is you're just plugging in the ABC and then simplifying it. And if you get a negative underneath the radical, you take out the I, you reduce it. And that's all it is. Okay? It's pretty straightforward working. It's just the formula. Now, there's something called the discriminant. Now, the discriminant's nice because it tells you how many answers you will have. And all the discriminant is it's the number that is underneath the radical. So this negative b, or this b squared minus 4ac, that is your discriminant. And what you'll do is that you'll plug in those numbers and see what you get. If the discriminant, or the number underneath the radical, is 0, you'll only have one answer, which means that your graph, the parabola, will only touch the graph at one point, or its vertex is on the x-axis. If you get a number that's positive or greater than 0, okay, you'll have two answers, which means that the graph looks something like that. Okay, as you see, it crosses at 2 points. And then the last one, you'll have two imaginary. That is if the graph will never touch it. So like this last one is if you get a negative in the discriminant, it never touches. 2 real means it touches twice. Its turning point is below the x-axis. And if it's 0, the turning point is on the x-axis. And that helps you find that with the discriminant. So now if you look at these, what you'll do is that you'll plug it into the discriminant. So the discriminant is b squared minus 4ac. So b squared, which would be 16, 4 squared, minus 4 times 1 times 5, getting us a negative 4. Since you have a negative number, that means that you're going to have two imaginary answers. Okay, you'll have two imaginary. Now if you look at the next one, you do the same thing. We want to move this 6 to the other side so it turns positive, because we want to set these equal to 0. That would give us a 49, or 7 squared. 49 minus 4 times 2 times 6. Okay, that would be 49 minus 48, which gets you a 1. And so that means you would have two real answers, okay, because it's a positive number. Okay, and so that's what the discriminant does. It helps you find how many answers you're going to have. So for your IRAT, what you're going to do is that you're going to identify the discriminant for each of these, and then you're also going to find the zeros for it. So you're going to use the quadratic formula, plug in those numbers, simplify it down, and see what you get. If you get a negative in the radical, use an imaginary number, use a complex number. Okay. And then also be sure you identify what the discriminant is for each of these. All right.